Good afternoon. First of all, I would like to thank to you, all professors and audience for being here today. And now, may I present about my research, which is the preparation of CO-absorbent composites based on alumina, chitosan, and copper-1 chloride. Before going through deeply, may I introduce the background of the CO-absorbent. CO is generally known as very poisonous gas, and also it can impact our environment by releasing a lot of air pollutants. On the other hand, the CO has a lot of industrial application to produce the valuable chemicals. That's why the CO absorbent is one of the essential requirements to capture the waste CO from industrial effluents. With this regard, the copper-1 chloride-based CO absorbent is industrially popular because the copper-1 chloride is a low cost and it has the high CO adsorption efficiency. However, with the use of the copper-1 chloride, it can be problematic when it is exposed to the air because the copper-1 chloride is readily oxidized to copper 2 plus ion, which cannot react with the CO anymore. That's why it can decrease in CO adsorption capacity. So, in order to solve these problems, only a few research work were reported till now, and they usually use the inorganic stabilizer for copper-1 chloride stabilization to get the stable CO adsorption capacity even under the moist condition. So how about another more eco-friendly organic stabilizer for copper-1 chloride-based CO absorbent composites? So that can be the chitosans, because according to the literature review, the chitosan has the valuable functional groups like the amino groups, which has the lone pair of electron, and also the hydroxide groups. These functional groups can make a bond with a lot of metals to make a complex, and among which the copper ion was reported to make a well complex with amino group. And on the other hand, one previous research reported the copper ions, copper metal, the well dispersion can be assisted by the addition of chitosan in his catalyst. So by this research review, I propose the chitosan modified CO absorbent with a 30% CuCl plus doping. Firstly, I want to identify if the chitosan really have the preservation ability for CuCl to get the stable CO absorption capacity even under the atmospheric conditions. And then afterward, I will analyze the effect of the chitosan addition amount on the stabilization proficiency of the CO absorption capacity. For the preparation of the CO absorbent composite modified with the chitosan, it includes three main preparation steps. The first step is the chitosan impregnations into the alumina support, and then the copper-1 chloride is doped into this chitosan modified support, and finally the calcination under the nitrogen atmosphere to get the nitrogen doped up carbon on the alumina, which make a bond with the copper. So after the preparation, I analyzed these parameters, and in the FTIR's analysis, after the calcination step, the chitosan original structure was disrupted, resulting in n-doped carbon on the alumina support, and the nitrogen from the carbon make a bond with the copper as a complex. That's why I found copper-nitrogen bond in the FTIR spectrum. Further XPS analysis to analyze the copper ion status in my samples. In the blank sample on the right side, the doped copper 1 ion exists in its original found, like the copper 1 chloride found. But in the chitosan modified sample, in addition to its original CuCl found, some of the copper 1 plus ion make a complex with the nitrogen of the chitosan. As similarly as in the XPS spectrum, also in the XRD spectrum, firstly, I determine the blank sample without chitosan. In that sample, I cannot identify the copper 1 chloride peak, although I have already analyzed its presence by means of the XPS spectrum. That can be because the copper 1 chloride originally have the small crystalline size, and this copper 1 chloride can be dispersed very well in the mesoporous alumina supports. In contrast, in the chitosan modified sample, the copper 1 chloride crystalline peak is very apparent to be seen. That is because the copper 1 ion make a complex with the nitrogen. That's why the resultant complex exists in well crystalline structure. That's why its crystalline peak can be detected. Then I characterized the properties of both absorbent. The absorbent without chitosan and the with chitosan has the mesoporosity. When I observed through the TEM spectrum, the chitosan modified sample shows the uniform pose distribution, although the blank sample without chitosan cannot show the uniform pose distributions. This time, I identified whether the chitosan really have the stabilization activity for copper 1 chloride in my CO absorbent. Firstly, I export the sample to the air for 30 days, and at each stage of 15 days, I check the CO absorption isotope. So it was clear that after the 30 days of air exposure, the blank sample without chitosan lost his initial absorption capacity. But the chitosan modified sample moderately maintained its initial absorption capacity only with a 20% reduction in CO absorption capacity. Also, when I analyzed the copper ion oxidation state by the XPS spectrum in the blank sample without chitosan, its copper ions proportions decreased dramatically after 30 days or air exposure. But interestingly, in the chitosan modified samples, the Cu1 plus proportion decreased only slightly. That may be because the formation of the copper 1 plus complex with the nitrogen from the carbon. Also in the XRD spectrum, I can still detect the CuCl peak in the modified chitosan sample. So by these analytic results and the isotope results, I can confirm that the chitosan definitely have the stabilization activity for CuCl-based CO absorbent to get the stable CO absorption capacity. This time, I want to know the effect of the chitosan amount on the stabilization proficiency of the CO absorption capacity. Among various proportions, as we can see that 0.15 chitosans sample give the highest CO absorption capacity as is fresh found. Moreover, even after the 30 days of exposure, it can still maintain its initial absorption capacity. And when I compared my optimum sample with the commercial samples, it is quite good absorbent. So afterward, I also analyzed the copper ion state in the optimum samples, and I found that most of the Cu1 plus ion exists in the complex bond. That's why the copper and nitrogen complexation can make the copper ion not to be oxidized and by resisting the air. That's why this time I consider the separation of CO from the CO2. Firstly, I estimated the CO selectivity factor after fitting the absorption data with the model called SIP model, and then I used the IT absorption solution theory, and by combination of these models and this theory, I calculated the CO selectivity factor, and its value is quite acceptable to separate the CO from the CO2. That's why, to conclude my presentation, this research work is believed to give some idea to use the chitosan as the potential organic stabilizer for CuCl-based CO absorbent composite to rent under the atmospheric condition. Thank you for your attention.
Any question from the audience? I have one question on slide 8. You mentioned that the addition of chitosan affected the pore size or surface area of the material, but can you explain again why the addition of chitosan affect the pore structure of the material?
According to the literature review, the chitosan is one of the dispersing agents for the metals on the samples. That's why by this literature review, the chitosan is believed to make the copper when ion dispersion on the alumina sample. That's why we can get the uniform pore size distribution in it.
Presentation. In your sample, you added chitosan, and then after that, the CO adsorption of purity and stability was enhanced, and probably the chitosan has a nitrogen component, so therefore the nitrogen component of the chitosan was helpful to enhance the CO adsorption performance and stability. And in that case, is it possible by adding nitrogen from other sources without chitosan, and then the CO adsorption ability can be enhanced just by adding nitrogen from other sources?
Yes. I think the other nitrogen source can also make the CO absorption CO absorption capacity enhancement. Yes, I think so. But because when I searched the literature review, some other researchers in the second researchers use the SMW. In this SMW, it contains nitrogen salts. Yes, and also he also proved that its CO absorption capacity can be maintained for 7 hours. Yes.
In the case, in the reference,
Yes.
is there any explanation why nitrogen can enhance the copper 1 plus stability in the CO adsorption? Can you explain the reason?
Yes. For my case. Okay, for my case, the nitrogen has the electron donors, and that's why it can make a bond with the Cu1 plus. Cu1 plus as a complex. According to the literature review, the complex has crystalline sites and when it's become a complex, its relativity is not too fast when compared to the uncomplex copper. Maybe the yes, I think I need more research on this in details. Thank you for your suggestion.
Okay, thank you for your presentation.